Everybody here? Okay. So today I will be solving the tutorial questions that will be shared to you maybe today or tomorrow. Okay. So the first question is compute the PDF. Everybody know about what is the PDF? Probability density function of the magnitude x of a circularly symmetric complex Gaussian random variable x with variance sigma square and 0 mean. Everybody is familiar with random variable, right? Random variable everybody knows? Okay. So, as sir has discussed, this x is a variable circularly symmetric complex Gaussian. So this means this variable x is a complex. So let's assume this is equal to x real plus j x imaginary. Okay. So this x is complex Gaussian. So we can write this x as Cn 0 comma sigma square. It means complex Gaussian with 0 mean and sigma square. Everybody knows this notation, right? Okay. So xr and xi. Do you know how they will be distributed? In the slides by sir, Tham sir, he has mentioned they will be distributed half-half. It means their variance will become half here. So this will be distributed as normal 0 mean sigma square divided by 2, and this will be distributed as normal 0 mean sigma square divided by 2. Okay. So when you add them, the total variance will become sigma square. Okay. This part clear? Now what you have to do? You have to compute the PDF for the magnitude of x. You know the transformation of random variable, right? Okay. Even if you don't know, we can compute the PDF from the CDF, right? Everybody know the relation between PDF and CDF, right? CDF is what? Cumulative distribution function. If we take the distribution, if we take the differentiation of the CDF, we will get the PDF. So if we can calculate the PDF of this, CDF of this, then we take the differentiation, we will get the PDF of that. Okay. So here, I am writing here x less than some variable, let's say a, or okay. So this is the CDF. Okay. Now this will be equal to what? I can write this as x equals to x square less than equals to a square, which is equal to, now x I can substitute this, I will get xr square plus j xi square less than equals to a square. Okay. This is easy. Now we can do the substitution. Let xr equals to r cos theta and xi is equal to r sin theta. Is this visible to everyone? Okay. So if we are doing this substitution here, so let's first write this in terms of integration form. So this represents what? A circle. So let's write C of circle A, and we have two variables here, xr and xi. Okay. So we will have like d xr and d xi. Okay. Let me check. Okay. And I have to write the CDF of f xr, f xi xr comma xi. Okay. If I calculate this region, the PDF of it, I will get this probability. Okay. This is okay. So I am calculating the probability. So probability, I need what? Distribution. So distribution is like this. Okay. So this represent what? Some region, circular region. So that circular region is this. So whenever I put the limit here, I will get this probability. Okay. Any question here up to this point? So now we will do this substitution and put this value. So what is fx here? Fxr, fxi. So as we have already seen here, these are normal distributed, Gaussian distributed with 0 mean sigma square divided by 2, and this is also 0 mean distributed sigma square divided by 2. So this value will be what? So f x r x I xr comma xi will be the multiplication of this. Can we write as a multiplication of these two values? So it will be 1 over root 2 pi sigma square divided by 2 into e to the power minus xr square divided by 2 sigma square divided by 2. You know what? You know the formula for the Gaussian distribution, right? And multiplied by 1 over root 2 pi sigma square divided by 2 into e to the power minus xi square divided by 2 into sigma square divided by 2. This is okay? I can simplify it further. It will be pi sigma square, this and this cancels out, and this becomes square into e to the power minus 2 and 2 cancels out here, and I will have x r square plus xi square. Okay? Divide by sigma square. This is okay? Everybody know the formula for the Gaussian distribution, right? Should I write again? So normally the formula for the Gaussian distribution is, if x is, let's say some y variable is normally distributed with, let's say, mu mean and sigma square variance, then we can write the PDF of x is equal to 1 over root 2 pi sigma square e to the power minus x minus mu divided by sigma square 2 here. Okay. So now I have here sigma square divided by 2. So I put here sigma square divided by 2 there, and here also sigma square divided by 2. So I write two expression there. It's sigma square divided by 2 and mu equals to 0. Okay. I then simplified it to this. Okay. Now if I convert, so with here I will write this expression here. Okay. And we have dxr and xi. Now I want to convert this variable into r and theta. So what will I do? So I have to take the Jacobian. Okay. So I have to write the Jacobian d r d theta and this is what I will have here, 1 over pi sigma square into e to the power xr square. So if I do if I put this here, what will I get? E to the power minus r square divided by sigma square. Okay. You understand the Jacobian, right? Everybody have heard about Jacobian before, right? So whenever we change the variable from one integration to another integration, one y this one. So there are two factors are coming, right? So they will be multiplied to this. Okay? Clear? There are two Gaussian distribution, right? So we multiplied them. Why did we multiply them? Because they are independent. Okay? So we multiplied them, we will get with this factor. Okay? So Jacobian here, so Jacobian is given by J r comma theta x r comma x I. So which is equal to del x r divided by del r del x I divided by del r del x r divided by del theta del x I divided by del theta. Okay? So Jacobian is this. Now we put the values here. Okay, so del xr divided by del r. So I will get what? Cos theta. And del xr divided by del theta, I will get minus sin theta. Cos theta is minus sin theta, right? And then what will I get here? Del xi divided by del r, that is sin theta. And this is what? I will get cos theta. Now if I take the absolute value of this, what will I get? Cos square theta and sin square theta plus sin square theta is 1. So this value is equal to 1, determinant value. Okay? Everybody following? Now, we are talking about, earlier we are talking about this xr and xi. Okay, now we are talking about these r values. So it means we are talking about a circle. Okay? So in circle, the value of theta can go from 0 to 2 pi. And value of r can go from 0 to infinity. Okay? So what we will have here, so let's clean this thing. So we will have one integration of theta and j is 1 e to the power minus r square divided by sigma square one thing is missing something. So here in Jacobian we have del xr divided by del theta. So I will get r here. Okay, right? So what will I get? Here I will get r. Okay, so this will be pi sigma square into r dr d theta, and here r equals to 0 to infinity. Okay, so now theta is independent integral, so you will get 2 pi. So 2 pi is okay, right? Now I have this integral 0 to infinity. What can I do here? I can put here, let's say u equals to r square divided by sigma square. Okay, so du equals to what? R dr divided by sigma square. Okay, so if u equals to 0, r equals to 0, r equals to 0 means u equals to 0, r equals to infinity means u equals to infinity, so limit remains same. And I will have e to the power minus u divided by pi sigma square, and r dr I can put du into sigma square. Okay. Right, sigma square. Okay. So pi and pi cancels out, sigma square cancels out. So what will I get here? 2 something is missing. Something is missing. Something is missing. So we had taken this circle. So we will get this circle. So this limit will go from r equals to 0 to this circle A, because this is circle limited, and this limit is also go from 0 to A. So we will get 2 and integration minus e to the power u into du, which will I will get 0 to A 2 e to the power minus u divided by minus 1 and 0 A, which is equals to this is A square divided by sigma square, A square divided by sigma square divided by sigma square. So 2 0, if I put here, it will be minus e to the power minus A square divided by sigma square plus 1. Okay. Please see if there is any error, or let me revise it again. So we have this condition here. After that we come here, we squared that, we write in terms of probability. Okay. Then we do the change of variable. For change of variable, we need to calculate the Jacobian. It comes out to be r. Okay. Then what we did, we put the value of the integration, theta equals to 0 to 2 pi, r equals to 0 to a. Okay. Then we put r dr equals r square d square, r square divided by sigma square equals to another variable. Okay. Then du equals to r dr divided by sigma square. So we put these changes, and what we will get, terms get cancelled out. This 2 pi comes out from this theta integration. Okay. So I will get 0 to a square divided by sigma square here, because we have changed the limit. So if r equals to a, then u equals to a square divided by sigma square. So I will get this integration 0 to a square divided by sigma square e to the power minus u du. So I take the integration e to the power minus u, I will get e to the power minus u divided by minus 1, and limit 0 to a square divided by sigma square, and 2 factor will remain here. So I will get, if I put the limit here, I will get 2 1 minus e to the power minus a square divided by sigma square. Okay. Any issue here? If you want, I can explain again. Okay. Now so our goal was to calculate the PDF here. Okay. We have the CDF here. Now we will differentiate it and get the PDF. So let's differentiate it. We have probability of x less than a is equals to 2 1 minus e to the power minus a square divided by sigma square. Okay. I want probability of x mod of x a, which is equal to dy dA probability of x less than a, less than equal to. Okay. Is this visible? So I will get, so this part will become 0, then minus 2, then I am differentiating this. Okay. So e to the power minus a square, it will remain as it is, then I will get another factor minus 2a divided by sigma square. Okay. So this comes out to be what? 2 a divided by sigma square into 1 minus e to the power minus a square divided by sigma square. Okay. Okay. The 2 factor is extra, right? So somewhere 2 factor. So here, so we have 2RDR. So 2RDR we have missed here. So 2 will also go there. So 2 factor will not come. Okay. 2RDR will go there. Okay. So this way you can calculate any distribution. So here we have calculated the magnitude of x. Magnitude of x is Rayleigh. So if your channel is complex Gaussian distributed, you can do the calculation by like this to get for the Rayleigh channel. Okay. So you should know this calculation. Even if you don't know what is the end result, but you should know the process. Okay. Because if you do like a BER calculation, then you need to calculate the expectation, variance, movements. So you need to do all these steps. Okay. So any question here, or should I summarize it again, or should I move on to next one? Summarize it again. Okay. So we have to calculate the PDF. We are given x. So x is complex Gaussian with 0 mean and sigma square variance. Okay. So x is complex. So every complex number has 2 parts, real part and imaginary part. Okay. So real part will have half the variance and imaginary part will have half the variance. Okay. So we are given variance of sigma square. So real part will have sigma square divided by 2 variance and imaginary part will have sigma square divided by 2 variance. Both will have. Okay. So what we did, to calculate the PDF, we calculate it from CDF. We have to take the differentiation. So we first calculate the CDF here. We have CDF formula is like this. Okay. We make the square here and we write in terms of XR, real and imaginary part. This represents a circle with radius limited to A. Okay. We write the probability like this. Okay. So there are 2 random variables. So we can write the joint probability distribution on them, and limit can be taken on that circle that is limited to A. Okay. Then what I did, I put the substitution for this one. I calculate, because this XR and XI represent the real part and imaginary part, and both are independent. So if I want to calculate their joint probability distribution, I have to multiply them. Okay. So both are Gaussian distributed with 0 means and sigma square divided by 2 variance. Okay. I have written both of them and multiplied them, and I can write this value. Okay. After this, I cannot simply calculate this value. So what did I do? I did the change of variable. Okay. From the Cartesian coordinates, I go to the polar coordinates. Okay. In the polar coordinates, I have r and theta. Okay. So if we do one change of variable, what we need to do, we can just differentiate. Okay. But if we want to do multiple variables change, we need to calculate the Jacobian. Okay. This is taught in BTech, maybe first year. Okay. So when you do multiple integration, multiple variable change, you need the Jacobian. Okay. So I calculate the Jacobian. So Jacobian with respect to x is above and r is here. So you can write the Jacobian. This is a simple way. First represent this row. These are the columns. So xr, xi, xr, xi. Then this is r and theta, theta. R and theta column wise. Okay. So this way you calculate it and calculate the mod value, determinant of it. This is the matrix. You calculate the determinant here. you will get this value. So I get this value r. Okay, I put the value here and put the limit here, I will get this thing. And here I did another substitution, I get this final result. Okay? And I did the differentiation to get the PDF. Okay? This two. This one? Yeah, 2 is not there. Yeah. Okay. Everybody clear? Okay. Yeah, when you do convergence to any variable, so let's say instead of x or xi, I do another type of variable, I need to do the Jacobian. So for example, I do one variable change here, u equals to r square divided by sigma square. So this is the one differentiation. If I do two variable change or three variable change, I need to calculate Jacobian. Okay, so for example, any other example? Okay, so let's say you have x equals to r, r1 plus r2 and y equals to r1 minus r2. Okay. Okay, so if I want to get, so my integration is in dx and dy. Okay, I want to change in terms of r1 and r2. I need to calculate the Jacobian. So j, so above we will have r1 and r2, and below we will have x and y. Okay, so how will I write Jacobian? It is very simple. First represent the row. So r1, r2, r1, r2, del, and second represent the column. So del by del x, and this is del by del y. Okay. Then I calculate the Jacobian determinant, and I will put the value. Okay. If any other step is not clear, I can also explain. Okay. So by this method, you can try to calculate the distribution of this. What will be its distribution? If you remember, Tham has already covered this in the slides. If you have seen clearly, you can answer this question immediately. What is the distribution of mod of x square? Okay? Exponential. Okay. So next question is about the bit error rate. Okay? Bit error rate for BPSK signals. Everybody knows about bit error rate, right? What is bit error rate? सबको पता है ना? ठीक है. So we have some equation, receive signal equation, y equals to h x plus let's say w, okay, where h represents the channel, x represents the BPSK bits, and w represents the noise, okay. So x is equal to plus minus square root of p, that is the BPSK signal, okay. So if I want to send 1, I will send square root of p. If I want to send 0, I will send minus square root of p, okay, and so on. And what is h? So h, say let is fixed. H is, let's say, fixed value at the moment, okay. We will also vary h and try to see what happens, okay. So let's tackle one random variable at a time, okay. So what is the random variable here? This is also the random variable, and x is also the random variable, okay. W is represent what? Noise. Noise is also random, okay. So W is what? W is complex Gaussian with 0 mean and sigma square, okay. So this W is complex, X is real, H is also complex, okay. So W is complex, so it also has real and imaginary part. H is complex, it also has real and imaginary part, but X is real, okay. Now, how will you decide from Y that you have received the signal plus 1 or minus 1, or you have transmitted 0 or not 0? What I mean to say, given the Y, what is your decision rule? What is your intuition say that we should decide this one or plus 1 or minus 1? Okay. So what is the decision rule? So decision rule, we can intuitively see that we are transmitting either plus side or either minus side. So we can make a hard boundary at 0. If our signal comes after 0, we will decide in favor of plus 1 or plus square root of p. If signal comes here, we will decide minus square root of p, okay. So it means we have to first exclude h, okay. So what we will do, we can, by intuition we can write real part of y divided by h greater than less than 0. So if it is greater than, then we will decide plus square root of p, and if it is less than, I will decide minus square root of p. Is this looks okay to you? Right? So what we are doing, we are dividing by h because h is fixed. So x will remain here and rest of it is noise, okay. So I am taking the real part. Why I am taking the real part? Because my x is real, okay. It doesn't have to do anything with complex thing, okay. If I want to check, I will check only the real part. I don't check the imaginary part, okay. So my decision rule is like this. No, I have assumed H is fixed complex. Yeah. Okay. Now let's calculate the probability of error. So probability of error is equal to, so can I say here my x hat, this is my x hat, this is the estimate of x hat. I mean, by this process I will get my estimate, okay. So probability of x hat not equal to x. So this is the probability of error, okay. So by this I can write, so I have two symbols. Either I am transmitting plus 1 or I am transmitting minus 1 or plus square root of p or minus square root of p. So I can write in terms of 2 here. So let's say I have transmitted x equals to plus square root of p. Okay, so I have to write here probability x equals to plus square root of p. So here, when is the error occurs? So if I am transmitting plus square root of p, my error will occur when this quantity is less than 0. Okay, so I will write here real of y divided by h is less than 0. This part is okay. Similarly, plus I can write here probability real of y divided by h greater than 0 if I transmit minus square root of p into probability x equals to minus square root of p. This part is okay? Everybody can understand this part? This is just law of total probability. Okay? So what is this probability? This probability is the this probability of this. So how the symbols are coming? Okay. So for example, we can assume this as 1 by half, 1 by half. Why we can assume? So let's say we usually assume it 1 by half, 1 by half. Why? Because usually we have two variables, so we can assume it uniform. For example, I can toss a coin and I can assign h to 0 and head to 0 and tail to 1. Okay? So I will have series of zeros and ones if I toss the coin multiple times. And that zeros and ones will have approximately half the probability of being 0 and half the probability of being 1. Okay? So we usually assume it to be 1 by half, 1 by half. Okay? Equiprobable symbols. So we assume equiprobable symbols. This is the assumption. Okay? If you do not have equiprobable symbols, you have to multiply the corresponding value here. Let's say 0.25 this and 0.75 this. Okay? Then you will get the probability. Okay? So let's solve these two equations one by one. Okay? So this equation is clear. First I am asking this equation is clear. Okay, so let's say this is PE1 and this is, let's say, PE2. Okay, so let's calculate PE1, which is equal to like this. So I can write this real part of y divided by h. So y is like this. If I divide by h, I will get x. So x is equal to square root of p plus real of w divided by h less than 0. This is okay? This thing I have written like this. Okay? Now, let's see this. Real of w divided by h. Okay? So let's say w has two components, w real plus j w imaginary. Similarly, let's say h has two components, h real plus j h imaginary. I am dividing w divided by h. So w divided by h, okay, I am taking the real part, okay. So I can write this as real of w divided into h star, conjugate of h, divided by mod of h square. This okay? Okay. Now I multiply w into h. So I have this. So how will I multiply this? So I will have WR HR plus, because this is conjugate, so this will become minus, and WI HI. Okay? This part clear? Should I expand more? This part is clear? ठीक है ना? Okay. Now we have WR is distributed as normal, 0 mean. So this is sigma square. So this real part will be sigma square divided by 2. Okay, and if I multiply this by HR, WR, this will be distributed as 0 mean comma HR square sigma square divided by 2. Now this everybody following or not? I have to ask. Okay. If I multiply by HR into WR, I will get here HR square because I am calculating the variance. Okay. नहीं समझ में आया तो इसको डिटेल में बता देते हैं. Okay. If you are not clear, I can explain in detail. Now, if I add these two terms, so similarly, HI, WI will be distributed as 0, comma, HI square sigma square divided by 2. And if we are adding that, HR, WR plus HI, WI will be distributed as 0 mean, comma, HR square plus HI square sigma square divided by 2. This part is clear? Now this is what? This is equal to mod of H square. Okay? So, so real of W divided by H is equal to what? This quantity divided by mod of H square. So, this quantity will be distributed as norm 0, comma H square sigma square divided by 2 divided by H to the power 4. Do you understand this thing? So whatever we have here, it is being squared here. Whatever we have here, it is squared here and added here. So in real divided by H, this thing divided by mod of H square. So mod of H square will come mod of H to the power 4 here. Okay. So I can write this thing as so probability real of W divided by H, that is norm 0, comma sigma square divided by 2 H square less than minus square root of P. Okay. Now this is, can anybody calculate what will be this value? Everybody aware of Q function? So Q function is the function to calculate the values on the normal distribution. Okay. So let me explain a little bit. So this is the normal distribution, right? So this is what? N 0, comma 1. Okay. So this is, let's say this is alpha. Okay. So this value I can denote by probability. Let's say this is X. So X greater than alpha. So this area will be denoted by this probability X greater than alpha. So I can write this as Q of alpha. Okay. This part is clear? So we have this Gaussian distribution, right? Okay, and we have some value here at alpha, okay, and I want to calculate this area, the value of this area. This value of this area is this probability x greater than alpha. This represent this, okay, this is the area, right? So how will you calculate this? You will calculate this by this integration. You will write the distribution of fxx, Gaussian distribution here, dx, and you write alpha for x equals to alpha to infinity. And what will you get? You will get this q function. So this is already if a ready-made, I mean like already set value that this type of integral will be denoted by this q function, okay. So whenever you get this kind of values on the Gaussian curve, you want to calculate the area in the Gaussian PDF, you can write this as q function here, okay. Now one more thing you can observe here is that Gaussian distribution is symmetric, okay. So similar thing you can see here. Let's say if I have here minus alpha, okay. So since Gaussian distribution is symmetric, the area here will be same as the area here, okay. So this is probability of what? Probability x less than minus alpha, okay. So x less than minus alpha is equal to x greater than minus x greater than plus alpha, okay. This part is clear? So this value also be q alpha, okay. This part is clear? Okay. So here we are talking about the similar thing, okay. So it means what? So we have, so we can convert it in terms of n01, okay. How do we convert it? We can just take this out, okay. So for example, I can write here sigma divided by square root of 2 h square, okay, into n 0, 1 then is equals to minus square root of p. This okay? So here what was I doing? I multiplying, and it was going in here square because it is a variance term, and here what I am doing, I am taking out to make it as unit norm, unit variance, okay. Now I can write this as probability n01 less than minus square root 2 h square p divided by sigma square, okay. Okay, this part is okay. Now the same thing here, I can write this as q function. So this value will be q square root 2 h square divided by sigma square into p, okay. So p by sigma square is what? SNR here. Why SNR? Because we have this equation, what we are transmitting here x, so power of x is p, because x equals to square root of p plus square root of p or minus square root of p. The total power is p here, and power here is sigma square, because w is distributed as complex Gaussian, 0 mean and sigma square variance, so power here is sigma square. So SNR is p by sigma square here. So the total, if we write in terms of SNR, we can write here q square root 2 mod of h square into SNR, okay. This part is clear. Should I summarize it again? So earlier we want to calculate the probability of error. We have given this equation. So h is fixed and complex. X take two values, plus square root of p or minus square root of p. W is complex Gaussian distributed. We calculate the probability of distribution, probability of error like this. To calculate the probability of error, we need the decision rule. So our decision rule was like this. So if I transmit plus square root of p, I will have error when it is less than 0. Okay. So by the law of total probability, I write these two equations, okay, because we have two random variable here. One is x hat and one is x, so I can write like this. Okay. So after that, I just calculated this thing PE1. So PE1 come out to be like this, and I have assumed this to be equiprobable. Okay. This is the assumption. Okay. So here I have calculated this. So if we put this here, and if you do the another derivation for PE2, you will note that PE2 comes out to be equal to PE1. Okay. So PE2 comes out to be equal to PE1. Okay. And this is 1 by half, 1 by half. So what will you get here is 1 by 2 PE1 plus PE2, and both are equal. So I will get here PE1. Okay. So your final probability of error will be the same. Okay. And here what I did, I have just followed the procedure for to calculate the unit norm to calculate the variance of the Gaussian distribution. Okay. So I just analyze this value. I break into parts, and for each part I have just written what will be distribution, and I have then added, and then I will get the final distribution. Then final distribution I just substituted here, and I write in terms of Q values. Okay. That gives me the probability of error.
PE2 is 1 minus PE1 or exactly equal to?
Exactly equal to. Both will be equal. You can try, okay? If it doesn't come out to be, let me know, I will tell you, okay?
Maybe if we assume equiprobably, that is okay, but if it is otherwise it is 1 minus.
Yeah, this thing. Yeah. No. They will come equal. They will come equal. You can calculate it.
In
Yeah.
any case also.
We are talking in terms of BPSK.
No. Okay. Equiprobable case, that 2 will get always same.
Yeah, equiprobable case is the like that's the worst case. I mean, if you know the entropy, right? Entropy means information. Okay. So we in probability of error, we always consider like the worst case. So whatever that happen, we should consider that is the that's the worst probability of error we can get. Okay. If we assume non-equiprobable, it means we are not considering the best case. Okay. Let's say if we do not assume them to these to be equal, even if these are equal, it will come out to be the same. Okay. Because these are same, then the final probability will be the same. Okay, this is 0.75, this is 0.25, these are equal. 0.75 plus 0.25 is this one. Okay. Because you see the entropy means what? It related to the randomness. Okay. So it gives you how much information you have. The more randomness you have, the more information. And uniform distribution has the most entropy. Okay. So if we are considering a uniform distribution here, it means we are choosing the best possible information here. Okay. So any question here up to this point? Is this clear to everyone? Okay. So H is today, sir, in Sir Tham's slide, he has shown that H is what? H is the coefficient for the flat fading channel. Okay. So tomorrow we will assume H is not fixed, and we will derive the probability of error. Okay. So this is just for the single flat fading channel. If we have multiple the signal from the multiple path, this becomes a summation. Okay. Then we have to analyze for the summation. Okay. It will become the more difficult. So here, instead of assuming fixed, now this will be a random variable. Now this will be a random variable, it will have a distribution. It will have distribution, then we have to calculate with the integration. Okay. That's the thing we will do tomorrow. Okay. Any more question? So this thing, the variance calculation, you can try on your own also. Okay. You know how to calculate the variance, right? The formula for it, expectation of x minus mu whole square of that, right? You try it on your own, you will get it. Okay. Okay then.
Any doubts on this? Everyone understood what is the meaning of flat fading or frequency fading, no? Any doubt in that? Because that is the basic for any wireless communication.
So this is flat fading. Okay. This channel is flat fading because there is only one coefficient here. Okay.